Silence cuts through humid tropical air. A dark shadow glides over dense canopy. No roaring engine disturbs the morning. Only a mechanical whisper stirs green leaves. This marks a quiet technological revolution, born inside cramped desert laboratories, forged by sudden wartime desperation. Many assume it watched endless cornfields first. Declassified documents prove otherwise completely today. The high sky originally belonged to soldiers. Agricultural pioneers would simply wait decades. Yet the core flying machine remains identical in spirit. It carries fragile precision glass lenses. It maps invisible surface chemical wounds. It detects moisture shifts instantly. In 1967, government engineers chased ghosts. They wanted completely silent reconnaissance wings. They needed absolute battlefield operational stealth. Dry desert winds tested every single bolt. Cold aluminum screamed under hidden structural stress. Heavy hydraulic oil dripped like dark tears. Then the prototype finally lifted gracefully. A fragile skeleton of polished aerospace steel, guided entirely by trembling analog radio waves. It climbed rapidly into heavy gray clouds. The brown earth disappeared below completely. A new aerial surveillance era quietly began. Watch the distant horizon carefully right now. The technological future always arrives softly. It never announces its own sudden arrival. It simply hovers above your quiet fields. Modern farmers inherited this exact blueprint. They replaced warheads with fertilizer tanks. They swapped combat zones for harvest seasons. The fundamental physics never changed at all. Gravity still pulls equally on every wing. Wind still tests every single joint. The sky demands absolute respect always. Glass lenses captured every single detail. Radio signals bridged vast empty distances. Human hands guided metal birds blindly. History recorded every successful landing perfectly. Engineers celebrated quietly behind thick concrete walls. Fear drove every single engineering decision forward. Cold War tensions paralyzed diplomatic negotiations completely. Commanders needed eyes above hostile territory. Manned aircraft drew constant heavy anti-aircraft fire. Pilots returned home in wooden caskets often. The military demanded a cheaper alternative. Budgets stretched thin across multiple branches. Tax dollars vanished into experimental research. Scientists needed a flying camera platform. It had to survive extreme weather conditions. It required minimal maintenance during long missions. The pressure felt like drowning in deep water. Every failed prototype cost precious development time. Competitors across the ocean advanced rapidly. National security hung by fragile threads. Engineers worked through endless sleepless nights. Coffee stains marked countless technical blueprints. They sought perfect aerodynamic balance silently. Weight distribution determined flight survival completely. Too heavy meant instant ground collision. Too light meant sudden wind destruction. They carved foam models carefully by hand. Wind tunnels screamed during endless testing cycles. Metal fatigue became their constant nightmare. They reinforced stress points with titanium alloys. The final design resembled a giant insect. Silent rotors spun at dizzying speeds. Fuel tanks held barely enough energy, yet it promised unprecedented operational endurance. That budget equaled constructing hundreds rural schools. Leaders chose aerial eyes over classroom desks. Survival demanded immediate technological superiority. They gambled everything on silent mechanical wings. The desert heat warped testing equipment constantly. Sand infiltrated every exposed electrical connection. Technicians wiped grease from tired foreheads. They recalibrated gyroscopes until dawn arrived. Each adjustment felt like threading microscopic needles. One wrong measurement meant total mission failure. The stakes exceeded simple scientific curiosity. National borders shifted under invisible pressure. Diplomacy failed to resolve territorial disputes. Weapons required precise targeting data daily. Satellites offered limited photographic coverage then. Ground troops navigated dense hostile jungles blindly. They needed real-time overhead guidance. The drone became their silent guardian. It watched over vulnerable marching columns. It mapped enemy supply routes accurately. Engineers felt the weight of history. Their sketches became actual flying realities. The workshop smelled of ozone and oil. Progress arrived through relentless trial and error. Every crash taught valuable hard lessons. Survival required absolute mechanical perfection. Step inside the aluminum fuselage carefully. Wires snake through narrow metal corridors. Copper veins pulse with electrical life. The power plant sits near the center. It resembles a compact mechanical heart. Pistons fire in precise rhythmic sequences. Exhaust heat warms surrounding air significantly. That thermal output matches industrial ovens perfectly. A wooden propeller slices heavy atmosphere, pushes 3 times its own weight. Vibration travels through every structural joint. Shock absorbers dampen dangerous harmonic frequencies. The camera bay occupies the lower nose. A single lens captures vast landscapes. Film advances with each mechanical click. Lens coatings reflect invisible infrared spectrums. Plants reveal hidden stress patterns clearly. Chlorophyll absorption drops during drought periods. The sensor detects these subtle changes instantly. Navigation relies entirely on magnetic compasses. Gyroscopes maintain horizontal flight alignment steadily. Radio receivers catch distant controller commands. Ground crews perform endless pre-flight checks. They tighten bolts with calibrated torque wrenches. Lubricant coats every moving metal surface. The machine breathes before takeoff sequence. Fuel gauges show minimal remaining capacity. Cooling fins dissipate dangerous engine heat rapidly. That thermal radiation matches desert pavement temperatures. Mechanics monitor oil pressure continuously. Red warning lights illuminate dashboard panels. Technicians interpret flashing signals quickly. Hydraulic lines carry pressurized fluid silently. Pressure levels match deep ocean floors. Metal seals prevent catastrophic system leakage. The landing gear folds neatly inward. Wheels retract like folding insect legs. Drag reduces significantly during cruising altitude. Structural ribs support immense aerodynamic loads. They distribute force across wide surfaces. Engineers designed redundancy into every system. Primary circuits fail during extreme stress. Backup relays activate automatically without warning. Flight continues despite sudden component failure. Longevity depends entirely on careful upkeep. Precision defines every manufacturing specification. Tolerances measure thinner than human hair. Logic flows through vacuum tube networks. Electrical signals mimic primitive neural pathways. The machine processes information mechanically. No digital code guides its movements. Operators control direction using physical joysticks. Thumb movements translate into rudder adjustments. Human reflexes dictate flight path constantly. Latency creates dangerous control delays. Commands travel through heavy atmospheric interference. Static crackles obscure clear radio transmission. Pilots navigate entirely by visual reference. They match ground features against paper maps. Coordinates guide navigation across unfamiliar terrain. Barometric sensors measure external air pressure. Rising columns trigger throttle reduction. Falling pressure increases engine output. Temperature fluctuations disrupt sensor accuracy. Engineers compensate using mechanical springs. Stability emerges from physical counterweights. Lead balances inside wing tips perfectly. They resist sudden gusty crosswinds effectively. Flight feels like walking tightropes blindly. Every correction requires immense mental focus. Operators sweat during extended missions. Hands cramp around control mechanisms. The machine responds to human intuition. It lacks independent decision-making capacity. It merely executes direct commands faithfully. Success depends entirely on operator experience. Veterans develop muscle memory gradually. They anticipate mechanical behavior instinctively. Flight becomes an extension of their bodies. Signal degradation worsens over mountainous terrain. Radio waves bounce off steep rock faces. Operators maintain course using dead reckoning. Compass needles point toward magnetic north. Rain interferes with mechanical linkages. Water droplets jam exposed control surfaces. Pilots compensate by increasing engine power. Calculations require rapid mental arithmetic. Operators estimate distance using ground markers. Rivers serve as natural navigation guides. Navigation relies heavily on visual landmarks. The sky offers no visible boundaries. Flight instruments become essential survival tools. Operators trust glass over intuition always. Military contracts dried up completely. Surplus drones sat in storage hangars. Engineers repurposed combat hardware for civilian use. Agricultural universities purchased decommissioned airframes. Scientists mounted multispectral cameras on wooden wings. They mapped crop health across vast fields. Fertilizer application targeted specific soil zones. The battlefield guardian transformed into harvest helper. Decades separated conception from practical farming. Miniaturization reduced payload weight significantly. Modern farmers command fleets silently. Tablets replace physical joysticks completely. Algorithms calculate optimal flight paths automatically. The original blueprint evolved beyond recognition. Yet fundamental principles remain perfectly intact. Aerodynamics still dictate wing shape. Sensors still detect chemical variations. The legacy lives in every harvest. Silent wings now feed growing populations. Innovation bridges military necessity with agricultural survival. Progress continues beyond current limitations daily.